Welcome to Mastering Solutions. In this projectile motion problem, they tell us that Emily throws a soccer ball out of her dorm window to Allison, who's waiting to catch it, and they tell us that she throws the ball at an angle of 30 degrees below the horizontal. So we'll say this is the horizontal, and it is 30 degrees below that. And they say that she throws it with an initial speed of 12 meters per second. How far from the base of the dorm should Allison stand to catch the ball? And assume that the vertical distance is 6 meters. So here down to wherever they catch it is 6 meters. Let's break up this velocity vector into its x and y components. So the x component, we can slide the y over like this. And here's the x. So the x component is going to be adjacent to the angle. So that's going to be cosine. And I'll do this quickly. We've done it a lot in other videos. Cosine of the angle is equal to adjacent over the hypotenuse. So we'll multiply both sides by hypotenuse, and adjacent is equal to h cosine of theta. So the x component is going to be a hypotenuse, which is 12. So 12 meters per second times the cosine of the angle 30. The y component will be the exact same math, except that we'll be using sine since it's the opposite to the angle. So it'll be 12 meters per second times the sine of the angle 30. So the x component is 12 cosine of 30, and the y component is 12 times the sine of 30. So we have 6 root 3 and 6, and that is going to be 10.4. The y component will also be negative because we're going in the negative y direction. So negative 6, 10.4 meters per second and meters per second. So how we want to approach this is we need to figure out first how long is the ball in the air for, and then we'll use the x component or the x component of the velocity to figure out how far from the base of the wall it's going to land. To find the time, we'll be using the formula of y final is equal to y initial plus the initial velocity in the y direction times time plus 1/2 times the acceleration times the time squared. If we say right here at the top where she throws it, that is y equals 0, the y initial will be 0, the y final will be a negative 6. Let's minus over y final as well. So 0 is equal to the negative y final plus the initial velocity times time plus 1/2 the acceleration times the time squared. I set it up like this because we'll be using the quadratic formula to solve for the time. So we can plug in the numbers here. So we have minus a negative 6 meters. The initial velocity times the time is going to be in the y direction, so it will be negative 6 as well. So negative 6 meters per second times time plus 1/2 the acceleration is going to be a negative 4.9 because 1/2 of negative g meters per second squared times the time squared. So now when we go to our calculator, we'll come down here to second and Pauli solver for ax squared plus bx plus c. Our a in this case is negative 4.9 ax squared and our t squared. Our b in this case is going to be the negative 6 and our c is a positive 6. So our times will be either 0.652, which is positive, or a negative 1.88. So t is either 1.88 seconds or a positive 0.652 seconds. Obviously, we can't have a negative second, so our 0.652 is how long it's in the air for. So lastly, we need to take this right here. I might use this whole phrase just so it's a little bit more precise than the rounded version that we had, but we'll take the time because velocity is equal to a change in a distance over a change in time. We want to isolate this, so we'll move t over. So x, or the delta x, in the x direction is going to be equal to the velocity times the time. So delta x is equal to the x component of the velocity, which we said was 12 cosine of 30, times the time of 0.652 seconds. So we have 12 times the cosine of 30 times 0.652. So the distance that it will be from the wall is 6.78. So we'll round that to 6.8 meters. So she needs to sand 6.8 meters from the base of the wall in order to catch the soccer ball.